Hi everyone. It's so I can't do anything, so I may as well make videos. Okay, so this is question number 2 from that whole packet from Friday's homework, and I'm going to start with part A. So people are entering this concert, and the rate at which they're entering is this piece right here. Okay, and this is only for the first 2 hours. And when t equals 0, there's nobody in the door. Okay, and then at t equals 2, that's it, the door is closed. Okay, so that's what we're working with. So how many people are in the auditorium when the concert begins? So that would mean in those 2 hours, so from 0 to 2. And then it's just going to be that function that we were given. And that's the whole thing. And also, if you wanted to, you could write it like this. Okay, personally, I like to write the whole thing out. That's just for me. I'm more a visual learner, but you can just write R of t. And then this is a calculated question. You're going to put it in your calculator, and you're going to get 980. So in this particular problem, what are we talking about? We're talking about how many people are in the auditorium when the concert begins. So 980 people. And the scoring for this was, let me get another car. If you just set up the integral, that was worth 1 point. And then if you got the answer, that was another point. So I think that's a pretty easy 2 points. Okay, now we'll move on to question B. Find the time when the rate at which people enter the auditorium is a maximum. And we have to justify that. So we have a maximum when the derivative equals 0. So that would be when is r prime of t equal to 0. So if we look here, that's our function right there, and we're going to take the derivative of that. We're going to get 2,760t minus 2,025 t squared. So that's r prime of t, and we want to set that equal to 0. And you're going to use your calculator again, and you're going to get, this is true when t equals 0 and t equals 1.36296. Okay, so we're going to have to figure out which one of these is going to give us our maximum, and don't forget also that this can also happen at an endpoint. So basically what we have to check is are the endpoints r of 0, r of 2, and then r of the 1.36, let's say 3, we'll round it a little bit. So you always want to test the endpoints and your critical points. Okay, I'm going to make some room. Okay, so I'm just going to write a little bit backwards. R of 0 was 0. They told you that anyway, that at time equals 0, there's no one there. At t equals 2, there was 120 people. And at r of 1.363, there was 854.5 people. So obviously, you'd have to round that. But the question is saying when is there a maximum? And you can see there's definitely more people here. So you would say the rate of the maximum amount of people entering. Sorry, I got this new stylus, which is, I don't know. Entering was at t equals 1.36929. It's not asking for the amount of people, so we don't have to worry about that. I just want to clarify one thing. In case you're saying, how come at r of 2 it's 120 when in part A we got 980? Okay, 980 was how many people are in the auditorium, and for part B, it's the rate at which people are entering. So at that time, That was the rate at which people were entering, not how many people were there. Okay, so these were your point values. And the point values for this part was worth 3 points. So you got 1 point for setting r prime of t equals 0. You got 1 point for finding the critical point, and then you got 1 point for the answer. So that was 3 points for that one. Okay, so now we're up to part C. So the total wait time would be how long did each person wait altogether. So if, let's say, Sophia was waiting 10 minutes, and then Caitlin was waiting 10 minutes, that means the total wait time was 20 minutes, but then you have to keep putting in more people in there, okay? So the wait time is just W, so let's just write that. Wait time equals just W. And then W prime is this. So we don't know what the function W is, but we do know that this piece here is the derivative. Okay, so they're saying to find W of 2 minus W of 1, the total wait time for those who enter the auditorium after time t equals 0. So this is the wait time for people that arrived from at 1 hour at t equals 1, and then through t equals 2 when the door closed. Okay, that's what we're doing. Okay, so we need to find W of 2 minus W of 1. Okay, so basically we're looking for the integral from 1 to 2. And that will be of W prime of t dt. So this is the integral from 1 to 2. And W prime is this function they gave you right here. Okay, and we already have the function for r of t. Okay, so if you wanted, you could rewrite it like this. I don't know if you can hear those snorting noises in the background. Jojo has a little stuffy nose. Okay, so that's actually the function. You throw it into your calculator. And you're going to get this. And let's just check the units. So it says, what's the total wait time? So this is wait time, so this would be hours. So of all the people that waited, if we took all their waiting times, it was almost 400 hours of waiting time. Okay, so the scoring is as follows. So this integral was worth 1 point, or you could have written it like that. And then the actual answer, that was worth 1 point. Okay, and finally this is part D, the last one, on average. So as soon as we see average, we're thinking about this formula. Because we said that's the average, how you get the average value. And so on average, how long would a person wait for the doors to open, and consider all people who entered? So that's from 0 to 2. Okay, so not just from 1 to 2 now. Now, keep in mind that, all right, so here's, well, this is what we're going to have to do. So we have from A to B, which is obviously going to be from 0 to 2. F of x is going to be this. Okay, and instead of r of t, you could actually write the function 1,380t squared minus 675t cubed if you want. Okay, but now we're going to have this 1 over b minus a, and it's not 1 over 2 if that's what you're thinking. Just want to tell you while I'm doing this, Jojo just had a bath, and her freezing cold, soaking body is on my arm right now. So if you wanted to know the total wait time average, you would take all the wait time of all the people, and then you would divide by how many people there were. And so how many people were there from 0 to 2? There were 980 people. So you have to divide it by 980. So if you do this, you're going to get 1 over 980. And from the integral on your calculator, you're going to get this. And when you do 387.5 divided by 980, you're going to get 0.77551. So the question is, on average, how long does a person wait? And you're going to say, on average, a person waits 0.776 of an hour. Okay, and these were your point values. If you set up the integral, that was 1 point, and then for the actual answer, that was 1 point, and that completes problem number 2.